Okay, welcome back. So in question number 5, you are asked to write skeleton equations, which means we just need to write the formulas for our reactants and our products, right, without a need to go back and worry about adding coefficients to do any sort of balancing. Okay, that's what a skeleton equation means. That's what we need to worry about. What are the reactants? The formulas for the reactants and the formulas for the products. All right. So in part A here, we have barium, right? So barium is not attached to anything, so that's just barium. So Ba, right, is the symbol for barium. And it's going to react with hydrobromic acid. And because we didn't talk about acids yet, I gave you the formula for hydrobromic acid. So I'm going to say Ba plus HBr. All right, yields, which we indicate with an arrow, barium bromide. Now, in this case, because we are combining barium with a new material here, we're going to need to know the charges. Barium's a metal with a +2 charge. Bromine is non-metal with a -1 charge, which means our formula is going to be BaBr2 plus hydrogen gas. And hydrogen, I hope you remember, is one of the 7 Brinkelhoff elements. It is diatomic, which means it gets that little 2 by it when it's by itself. Okay, so again, if you are somebody who doesn't quite understand why I put that 2 there, what made me decide to write BaBr2 instead of Ba2Br or BaBr, right? Why did I write it like that? Now, that is a Unit 4 topic. So last unit, we talked about how to write formulas for ionic compounds. We know it's ionic because barium's a metal and bromine's a nonmetal. Whenever metals with a nonmetal, we use the charges to identify that formula. So again, if you are unsure how I got this formula, you need to go back to this slide where this video is linked and watch the basic ionic bonding review produced by the amazing Tyler DeWitt. All right, so that's a skeleton equation, and this is not balanced, but it says you don't need to balance, so we're not going to worry about that right now. All right, next one. We have iron 3 nitrate reacts with sodium carbonate. Okay, now this little 3 right here means that this is a +3 ion. And nitrate, that ATE at the end, tells me that it's one of my polyatomic ions, right? So you're going to flip to the back side of your periodic table and you will see, right, that that is a 1- charge, right? So again, crisscross applesauce method tells me we need 3 nitrates, 1 iron. The way that I write that is iron, whose symbol is Fe. Now nitrate is a polyatomic ion, NO3, right? Now that 3 is part of nitrate. So the 3 that was already there does not come from this 3, right? Now, whenever it says nitrate, you write NO3, and that 3 oxygens and 1 nitrogen is what makes it nitrate. So this is not showing 3 nitrates. Right now, it shows only 1 nitrate because nitrate is one of this whole thing. So if I need to add a subscript to nitrate, as indicated here, I put parentheses around it and put the 3. Now, I just reviewed how to write formulas with polyatomic ions. So again, if this is confusing for you, right? If you're not sure what I just did there, go back and watch the video on the slide that this was linked on. It says ionic compounds or ionic formulas with polyatomic ions. Go watch that. That's how this process works. Now, the next one, we have sodium, whose symbol is Na, and it's a +1. And carbonate, again, that ATE ending tells me that's CO3, not just carbon, right? Which has a 2- charge. I'm going to put a 2 there and 1 carbonate. So this is going to be Na2CO 3. Now notice that 3, right, is a part of the carbonate polyatomic ion. So I don't change that number at all. Carbonate is CO3. So if it says carbonate, I have to put the 3 oxygens with the 1 carbon. If I needed to add a subscript, I would put parentheses around it and then put the subscript. That's something you should know by now. All right. Now, yields. That's that arrow sign. Iron 3 carbonate and sodium nitrate. So this is a double replacement reaction. So I'm just going to add iron and carbonate together. So iron is Fe3 plus, carbonate is CO3 2 minus, right? So mismatched charges. So we need 2 irons, 3 carbonates. I'm going to write that as Fe2 parentheses CO3. Now, I'm adding a 3 subscript by putting parentheses around the carbonate and putting a 3 plus sodium nitrate, Na plus and NO3 minus. They're both 1s, so we just put them together, NaNO3. Notice that 3 stays, because that's what makes it nitrate. All right? And then cesium, so that's just Cs all by itself, reacts with iodine, I2. Now, iodine is one of the 7 Brinkelhoff elements, which means it's diatomic. Yields cesium iodide. So cesium is a 1 plus, iodine is a 1 minus. They're equal and opposite, so we just put them together. CS